Alright everyone, this is lesson 4.6, practice B. And let's go over number 2. So in this triangle, we know that we have two congruent sides. So opposite from those sides are congruent angles. So this angle and this angle will be congruent. So since it's a right triangle, we know that the two acute angles have to add up to 90 degrees. So I would just take 90 divided by 2, and each angle is 45. So if each angle is 45, set 3x equal to 45, and set y plus 7 equal to 45. So if 3x equals 45 and we divide by 3, x is equal to 15. And if y plus 7 equals 45, subtract 7 from both sides, and y is equal to 38. For number 4, decide whether enough information is given to prove that the triangles are congruent and explain your answer. So I'm just going to mark up the diagram, and I'm not going to write down my explanation, but I'll explain as I go here. So the first thing that I see is that the two triangles share a side. So I mark RT is congruent to RT, and that's by the reflexive property. I see that the big triangle, SRU, has two congruent sides. So if these two sides are congruent, then the angles opposite from them will be congruent. So angle S is congruent to angle U, and that's by the isosceles triangle theorem. Then I also see that I have a right angle right here, so I know that I would have a right angle on the other side by the definition of perpendicular lines. So with all this information now, I see that the triangle on the left, I have an angle, and a side this way, or an angle, and a side that way. So we could prove that these two triangles are congruent by angle, side. We could also use, since this is a right triangle and the side opposite from the right angle is marked, which is called the hypotenuse, and one of the legs of the right triangle is marked, so this side right here is a leg. So this triangle is congruent to this triangle by hypotenuse leg. So there's actually two different ways to prove these two triangles are congruent. On number 6, since I have parallel lines here and here, then my corresponding angles would be congruent there and there. Likewise, I have parallel lines here and here, so my corresponding angles here and here would be congruent. So, by the corresponding angles postulate, angle TRU is congruent to angle RQS, and also by the corresponding angles postulate, angle T is congruent to angle QRS. But we don't have any sides marked congruent. So for all the congruence methods, you have to have at least one side, one pair of sides marked congruent. So since there are no sides congruent, it is not possible to prove that these two triangles are congruent. On number 8, we want to solve for x and y. So we'll solve for x first. We have an isosceles triangle. Since these two sides are congruent, then the angles opposite from them will be congruent. So since this angle is pointing to is 2x plus 11, then we can say that this angle is also 2x plus 11. So we know that all three angles must add up to 180. So we have this angle, and this angle. So x minus 2 plus 2x plus 11, and then the other base angle would also be 2x plus 11, altogether equals 180. So we would combine all of our like terms and get 5x plus 20 equals 180. Then subtract 20 from both sides. So 5x is equal to 160. Then divide both sides by 5. And x is equal to 32. But we also want to solve for y. So y is pointing to the base angle of this smaller isosceles triangle. So since it's isosceles, then these two angles will be congruent. So if this angle is y, then this angle is y. So we could just subtract our vertex angle from 180 and then divide by 2. Or we could say that this angle is y plus this angle is y plus the vertex angle, 142, is equal to 180. So if I combine my like terms, I get 2y plus 142 equals 180. If I subtract 142, I get 2y is equal to 38. And if I divide both sides by 2, I get y is equal to 19. So for number 10, we want to write a 2-column proof. So let's start off with this piece of given information. So we will say that FG, mark it on your diagram, is congruent to FJ. Reason is given. Based on the fact that these two sides are congruent, then the angles opposite them have to be congruent. So opposite from this side would be angle G, and opposite from this side would be angle J. And that's by the isosceles triangle theorem. We are also given that HG is congruent to IJ, so mark that. And that is also given. So now, if I look at triangle FGH or triangle FJI, I notice that I have two sides and the included angle marked. So this triangle, I have a side marked, an angle marked, and a side mark. Same with this triangle, side mark, angle mark, side mark. So these two triangles are congruent by side angle side. Now that I've proven that these two triangles are congruent, all of their corresponding parts will be congruent. For example, FH will be congruent to FI, which is what we wanted to prove, that HF is congruent to IF. So those two sides are congruent by CPCTC. Corresponding parts of congruent triangles are congruent. On this sheet, proving congruence, it says draw straight lines to match each statement within the proof to its reason. Each set will have an extra unused reason. The uncrossed letters will spell out a word. So some tips over here. First, by the reflexive property, a segment is congruent to itself. So anytime two triangles share a side, we mark that by the reflexive property. And also you should know that this symbol indicates parallel lines. So in our first proof here, we are given that LM is congruent to LO. So LM is marked in the diagram, LO is marked in the diagram. So we are given that those two are congruent. We are also given that these two are congruent. So MN is congruent to ON. And that's the next statement here. So we can draw a line to given for that. Then LN is congruent to LN. That's by the reflexive property. So draw a line to that one. And mark that in your diagram. And now we have enough information to say that triangle LMN is congruent to triangle LON, and that would be by side, side, side. So we have three sides of one triangle congruent to three sides of the other. Sorry about that. I was having technical difficulties with the software here, but I'm back up and running, and I just wanted to finish this proof. So triangle LMN is congruent to triangle LON, so we draw a line up to side, side, side.